The area of a right angled triangle is 54 centimeters squared. The side lengths of the triangle are A, B, and C, where A, B, and C are positive integers, A less than B, less than C. What is the value of C? So we'll draw a right triangle, and let's say label it A, B, and C, I guess, abiding by that rule. And because it's right, we also know that A squared plus B squared is C squared. And then they also told me the area is 54. So 1/2 base times height is 54. And therefore, A times B is 108. And that means that we could probably do this by inspection. Yeah, because they've told us that they're integers, right? A, B, and C are integers. So I'm going to go with 9 and 12 for A and B, right? Because 9 times 12 is 108. Okay, that fits. Let's see what happens. So we have 9 squared plus 12 squared is C squared. And our hope is that we're going to get a Pythagorean triple. And indeed we do, because 225 is therefore equal to C squared, and C is equal to 15. And 9, 12, 15 is indeed a Pythagorean triple. What do they want? The value of C. Well, that would be 15. The triple x, y, z of integers satisfies the following system of equations. If p is equal to the product x, y, z, what is the integer formed by the rightmost 2 digits of p? Okay, so let's, I'm going to make some substitutions here. I'm going to let 2 to the x equal a, 2 to the y equal b, and 3 to the z equals c. And when I do that, p is equal to x, y, z. Okay, well, obviously that's going to be calculated at the very end. But the reason I did this is because I'd substitute those into these equations. So in equation 1, that's going to be a plus b over c over 3 is 2259. In the second equation, it'll be a times b plus c is 7073. And in the third equation, it would just be a plus b plus c is 6633. And then I think, obviously, I think that looks a little bit nicer than these guys in terms of trying to figure this out. Okay, so this is just a system of equations. 3 variables, 3 equations. We can find out the values for a, b, and c. And then we'll later find out the values of x, y, z. Okay, so where do I go with this here? A, B would be 7073 minus C. And, well, C, we don't know the value for C yet. Oh, okay. Well, from the first equation, A plus B would be 2259 over C over 3. And from the last equation, A plus B would be 6633 minus C. So therefore, this is equal to that. Okay, that's definitely very helpful. 2259 minus C over 3 is equal to 6633 minus C. Okay, that's going to help us solve for C. So C minus C over 3 will be 6633 minus 2259, and therefore 2C over 3 is equal to 4374, and therefore C, when you crunch this out, is 6561. All right, great. We got one value. So then go back here, and then there'd be 7073 minus 6561, and I believe that's 512. Okay, so I still have to figure out A and B individually. Well, I guess I can put one in terms of the other, so A is equal to 512 over B, and then just sub that into one of these guys. Yeah. Any one of these equations. Yeah, I think that'll work. So which one should I use here? A plus B. Well, either one, because the values would be the same. So A plus B is 6633 minus 6633, let me just write it out, minus C, and C is this guy, so 6561. So A plus 512 over B is 512 over A. Yeah. And then that's going to be 72, I believe. Oh boy, we got a quadratic. Just more work for me, that's all. All right, here we go. Well, multiply through by A, so we get A squared plus 512 is equal to 72A. Put everything on what side? Let's see if this factors. Hopefully it factors. I don't have to do a quadratic. Oh boy. Can I divide through? Can I divide through? I think A 64 and 8 should do it. Minus. Yeah, so that means it's either 8 or 64. And there was an equality here somewhere. Was there an equality? Or no, I think I'm thinking of a previous question. So which one would it be here? Well, it doesn't really matter, because if we use this, where is it? This guy right here, that one, we get B. And B would either be 64 or 8. So it's interchangeable, and there's no inequality that I had previously thought. So it doesn't really matter what's greater, what's less. Okay, we got it all. Okay, so let's go back to these guys. So A, it doesn't really matter. I'll set that as 8. B, I'll set as 64. And C was 6561. Is that right? For some reason, that seems a bit large, but that's okay. Well, by inspection, we can easily figure out that X here is 3. Y here is 6. And 3 to the power of 8 is actually 6561. So that would mean Z is 8. Yeah, 3 to the power of 8. Okay, so then now finally we get to do this product XYZ. That would be, hold on. What did I do here? I think I forgot to write them in, is what I write. Okay, so X is 3. Yeah. And then Y is equal to 6. And then Z is equal to 8. Right. Okay. All right. Got to make sure I do that properly. Okay. So then XYZ would just be 3 times 6 times 8. And 3 times 6 times 8 is, I believe, 144. And what are they looking for here? The integer formed by the right two most digits of P. Ah, okay, so just the right two digits. So I guess just the 44 is what they're looking for, I believe. When two ants work together, they can build an anthill in 24 minutes. When the bigger ant works alone, an anthill can be built in 14 minutes, less than when the smaller ant works alone. How many minutes does it take the smaller ant to build an anthill when working alone? Okay, so before I get started, I want to explain this with some numbers, otherwise it will be too abstract and you may not understand it. So let's say you have some hill, right? Anthill. And I don't know how many bricks it has, but let's say it's made of bricks. I know anthills are not made of bricks, but I'm just kind of a house, let's say, whatever. And you've got two ants. So we've got the big ant. We'll call the big ant B. Let's say big ant. And we have the small ant. And each of these have a certain pace that they work at per minute. Now let's say, this is just an example to illustrate what this question is talking about. Let's say the first ant, the smaller one, can lay down 5 bricks per minute. That is the rate that this small ant works at. Then the big ant, it's a little bit bigger, so it can do 10 bricks per minute. It can lay down 10 bricks per minute. And I'll choose the 24 minutes, that's fine. So that will be 5 times 24, and this will be 10 times 24. So that is 120 plus 240, so 360. So that basically means that this house or hill or whatever it is made with 360 bricks. Well, at least just in those 24 minutes. In 24 minutes, we can build 360 bricks into this house or hill or whatever. So that's just an example to illustrate how this question will be approached. So now I'll keep that on the screen and just now do it, but with letters. So hopefully now you understand how it's done. The letters won't throw you off. Okay, so here we go. Then what we have to do is we have to look at the next sentence, that the bigger ant works alone. When the bigger ant is working alone, the time is 14 minutes less. So that basically means that B, whatever the rate is, remember this time I just going to put the letter B for the bigger ant because I don't know. I've chosen 10 bricks per minute just as an example. But in the actual question, I have no idea what the rate is, so I'll just represent it as B. B per minute, whatever the amount is, times t minus 14. And that is equal to H. The next sentence, which is basically the same sentence, the small ant, which I'll call A, working alone would be a time of t, and that is H. Right? That's the interpretation of that sentence put into math. Okay, so then we proceed from there. So we are going to try to figure this out. And I think our goal is to figure out the value for t, I believe. Now, let me go back and check here. How many minutes does it take the smaller ant to build an anthill while working alone? Yet our goal is to find t. All right. The only thing is that we have 4 variables, actually. And we only have 3 equations. So somewhere in here, something's got to cancel, and maybe it does. But let me just keep going here. So the full house, when we were working together, this kind of scenario, would be H is equal to A times 24 plus B times 24. Let me just double check that here. When 2 ants are working together, they can build an anthill. So the entire anthill is built in 24 minutes. Okay, that's what I was hoping for. All right, so that, I guess, gives us another equation. So we still only have 3 equations with 4 variables, but that's okay. Let me just divide through by 24, and then it'll give me just A plus B. And then I will use these equations. So this one, A would be H over T, and from this one, B would be H over T minus 14. And then I can sub those into here. So this would be H over T, and this would be H over T minus 14. Okay, that's very good. That's what I had hoped. The H's are going to cancel, and that just leaves T as a variable. Because I noticed like we were 1 equation short. We had 1, 2, 3 equations, but we had 4 variables. We need the same number of variables as equations to figure this out. But sometimes, like as you can see, something cancels, and that helps us out. So canceling out the H's, we just get left with this. And now we can proceed to figuring out the value for t. So this is just fractions now. So t minus 14 plus t all over t times t minus 14 all over 1 over 24. So t times t minus 14 is equal to 24 times 2t minus 14, I believe. And then this is going to be t squared minus 14t minus is equal to 48t minus 336. Put everything on one side. T squared minus 62t minus 336. And let's see if this factors t. Oh boy. 56. This 336. 336 divided by 56. Yeah, it does. So 56 and 6. Oh boy. The sign somehow. This is a plus. That's why. Oh boy. It's a good thing I made that. Notice that mistake. Yeah. Okay, that makes sense. Then this will be minus minus. Okay, great. So t is either 6 or 56, but obviously it's got to be 56, just common sense, because when they're both working together, they do it in 24 minutes. So if the small ant is working alone, it would obviously take longer. So it's not going to be 6, so therefore the answer would be 56. So you can just write that out. But on this question, they only care about the right answer. It's not full solution, so you don't have to explain why 6 is incorrect. So just as long as you put 56, you will be getting the question right. Suppose that f at x is equal to x to the power of 4 plus px to the power of 3 plus qx squared plus rx plus s for some real numbers p, q, r, s. In addition, f at 1 is 59, f at 2 is 118, f at 3 is 177. If t is equal to f at 9 plus f at minus 5, what is the sum of the digits of the integer equal to t? All right, so we have to analyze these guys. We have f at 1 is equal to 59, f at 2, which is equal to 118, which is basically 2 times 59. That's the first thing I noticed. I don't know if that means anything. And f at 3 is 177, which I believe is 3 times 59. Okay, so that might help in some way. I'm not sure how. Well, if we have another, I can introduce this. And if I let it equal 59x, then g at 1 would be 59, which is f at 1. G at 2 would be 59 times 2, which is 118, which is f at 2. And g at 3 would be 59 times 3. Sorry, I probably shouldn't have wrote it like with the bracket. Yeah. I mean, some of you understood what I did there, but the bracket makes it look like a function. So maybe I shouldn't have wrote it as a bracket. Let me just put a dot. Or just, 59 times x. So that would be 177, and that's f at 3. So that might help. Okay, let's see where we're going with this now. So if we then subtract the two, so if we have, let's say, f at x minus g at x, then that might help us get rid of some variables. So let's introduce that as a new function. Now let's see what we get. So if we have what would this be actually? It would be x to the power of 4 plus px to the power of 3 plus qx squared plus rx plus s minus g at x, and g at x is 59x, right? Okay. Does that help in any way? Well, Well, one thing is for sure, that we know the roots. H at 1 would be f at 1 minus g at 1. And f at 1 is 59, and g at 1 is also 59. So that's 0. So therefore, 1 is a root of h at x. Okay, that's helpful. And then h at 2 is f at 2 minus g at 2, which is 118 minus 118. And therefore, x equals 2 is also a root. And h equals 3 is f at 3 minus g at 3. And that's 177 minus 177. Again, a root. So is 3. So that's a pretty helpful finding. So therefore, h at x, if those are roots, would be x minus 1 times x minus 2 times x minus 3, right? But h at x is of the 4th power, correct? Because it's, if you look at here, you got x to the power of 4, and f at x is part of there. So because it's the fourth power, we also have to multiply by something else. So we'll just put x minus a fourth root. So put a fourth root here as a. Okay. So now we're getting somewhere, I think. This is helpful. This is helpful. Okay, now let's go back to the t and see what we get. So t is talking about f at 9 and f at minus 5. Okay, f at 9 and f at minus 5. Okay, so let me put that over here. It's f at 9 plus f at minus 5, actually. That's what it's saying. All right. And h at x plus g at x is equal to f at x. Correct? So that basically means that t is equal to h at 9 plus g at 9 plus h at minus 5 plus g at minus 5. Okay, I think that we got it. Well, we still have to calculate it, but I think because g at x is this guy right here, and h at x is here. So I think this should not be a problem. So let's see what we get. So h at 9 would be 9 minus 1 times 9 minus 2 times 9 minus 3 times 9 minus 8. G at 9 is 59 times 9. Okay, that's pretty easy. And then h at negative 5 would be negative 5 minus 1 times negative 5 minus 2 times negative 5 minus 3 times negative 5 minus a plus 59, which is g at negative 5 is 59 times negative 5. Okay. My hope is that the a's somehow cancel, but let's see what happens. So the first one, this whole thing, is 336 times 9 minus a. And then 59 times 9. I'll just factor out the 59 from these two guys, and I'll get 9 minus 5. Yeah. And then the other one, this one here, this whole thing here, is 336 times 9. Hold on, let me see for a second. 336 times 5 plus 8. Yeah, like that. Okay, so we're getting there. This is t. So if I factor out the 336, I'll get 9 minus a plus 5 plus a. And then this is 59 times 4. Aha, the a's cancel, which is great. That's exactly what I was hoping for. 336 times 14. 59 times 4. We have a number. Perfect. And that number is 4940. And what do they want? The sum of the digits of the integer equal to t. Okay, so this is the integer equal to t. The sum of the digits would be 4 plus 9 plus 4 plus 0. And that, I believe, is 17. A sequence A1, A2, and so on has A1 equal to 1, A2 equal to 3, AN equal to minus AN minus 1 plus AN minus 2 for each integer n greater than or equal to 3. For example, if A3 is equal to minus A2 plus A1, it would be negative 2. How many of the 2,025 integers A1 squared, A2 squared, A3 squared, and so on until A2025 squared are divisible by 2025? Okay, so 2025 is what we want everything to be divisible by. But 2025 is 45 squared itself. So we want these numbers to be divisible by 2025, correct? But 2025 is 45 squared, so any such number would be divisible by 45. Now 45 is actually 9 times 5. So if a number is divisible by 45, that means it's divisible by 9, and it's divisible by 5. Okay. And I don't know why they squared them. You see these numbers here? I don't know why they squared them, because if A1 squared is divisible by 2025, that means I'm not sure what the point of squaring them is. I guess we will find out as we progress. So let me just leave that for now. I think we can just concentrate on A1, A2, A3, because if their squares are divisible, then the numbers themselves would be divisible because the numbers would be very large. But let's see what happens. Okay. So the first thing we need to do is we need to get, or at least identify some sort of pattern. Identify a pattern. Now, these kinds of questions, sometimes the pattern is identified very early and sometimes it's identified very late. So it's very time consuming. But let's see. Since this is basic math here, we can calculate some of the first few. So they've already given us like the first ones. A1 is 1, A2 is 3, A3 is minus 2. So like that, using that recursive formula that an is equal to minus a n minus 1 plus a n minus 2. Let's calculate, I don't know, a healthy number, like the first 30 or so, to see if there's any kind of pattern. All right, so it's relatively simple math, so you can probably do this fairly quickly. I mean, it is a bit time consuming because the numbers do get a bit large, but without too much pain, you could get the first 30 or so. So now let's look at them. Let's look at them, concentrating on these two requirements. So here we go. Let's keep this all on the same screen if I can. Okay, so let's see, what do we have here? How many of these numbers, which are defined as AK, I believe, right? Do they use the term K in here? Because I just did. Well, I just did. So basically where K is between 1 and 2025, right? Yeah. How many of these are divisible by 5? Let's try with 5 first. Well, when you look at these, it is, you can identify this one here. This one looks like it's divisible by 5. This one, as long as it ends in 0 or 5, it will be divisible by 5. This one, and let me see, this one. Okay, so what I noticed is that would be for k is equal to 4, 9, 14, 19, 24, 29, and 34. So there is a pattern. It goes up by 5 every time. You notice? 4, then 5. If you add 4 to 5, it's 9. 9 plus 5, 14. 14 plus 5, 19, and so on. So that's a very good pattern. It's nice to have identified that. Okay, now let's move on to the next one. How many are divisible by 9? This requirement. Okay, 9 is not as obvious. So let's see here. 9. Probably have to use your calculator, but this one, well, that's an easy one. That's 9 times 9. This one is divisible by 9. 26073. And in our list, this one is also divisible by 9. What is it? 8, 3, 9, 5, 4, 2, 5 divided by 9. Yes, is an integer. Okay, so divisible by 9 for k is equal to 10, 22, and 34. Okay, so that's good because we got a common number. The first number that is in common is k equal to 34. See, it's on this list and it's on this list. So that's really helpful. Now at this point, there's a temptation that you say, well, every multiple of 34 must be divisible by both 8 and 9. Must be divisible by both 9 and 5, but I don't think it's that easy. Like, 34 and then 68 and so on. I don't think that's the case. So that's why this question is a bit, well, not a bit, it's quite challenging and quite time consuming. Okay, no problem. Let's just keep going with this. These are very good findings right here. These two. And let's extrapolate. So extrapolating, and I'm not sure why I'm using green. Let's go back to black. Let's keep expanding this. Yeah. So we had the 4, the 9, the 14, the 19, and 24, the 29, and 34, right? So let's keep expanding that list. And the good news is we don't have to keep calculating those numbers, because those numbers have become very big, as you can see. That's already up to 8 million something, right? 395,425. But we can extrapolate these lists fairly easily. So we got 30. We just have to keep adding 5, right? So 39, 44, 49, 54, 59, 64, 69. Let's go up to 100. 74, 79, 84, 89, 94, 99. Okay, and then what we're trying to find is the next common. So the next common number. So we got the first common, that was 34, k equal to 34. That was the first common. Then we have to find the next common. Okay, let's do the same thing with this list here. So that one looks like it's going up by 12 every time. 10 plus 12 is 22. 12 added again would be 34. So 22, 34, that'd be 46, right? 46. And then 58, 70, 82, 94. Okay, well, guess what? We found in the next one. The next common is this guy, 94. Okay, so that is the conclusion we wanted to come to, is what is the pattern for both? We found patterns for each divisible by 5 and divisible by 9, but what's the pattern for both? Numbers that are divisible by both 9 and 5. And that looks like 30 for k equals 34, then 94. And if you extrapolate this pattern, it is of the form ... 34 plus 60n. So just like how this was 4 plus 5 times something, whatever you want to call it, j, and this was 10 plus 12 times something, let's call it, I don't know, m. This is 34 plus 60n. Okay, so therefore, since our k's are between 2025 and 1, we can put this into that. So it would be 1 is less than or equal to 34 plus 60n is less than or equal to 2025. Okay, moving right along. So now we're going to have to do some algebra. First, let's... first we have to subtract the 34 from each side. So minus 33 is less than or equal to 60n, less than or equal to we're subtracting 34 from each side, right? Yeah. 1, and then divide through by 60. So minus 33 over 60, and then 1991 over 60. So this is going to be a very small number. Got 33 divided by 60 is minus 0.55. And then the other one, we got 1991 divided by 60, 33.183. So n is an integer. So n is going to be anything from 0, 1, 2, all the way till 33. And that is a total of 34 integers. And for each of those n's, you will get a k. So for example, when n is 0, k would be, well, this is k. So k would be 34. For n equals 1, k would be 94. K equals 2, k would be 154, and so on. You guys got you guys understand what I just did there, right? Just plug in n into this formula right here. And that's it. 34 is the answer to this question that is saying how many of those numbers would be divisible by both 9 and 5. Final point, I think I had touched on it briefly in the beginning. If a number is divisible by both 9 and 5, its square would most definitely be divisible by 9 and 5, right? So for example, just to prove it, if you have, let's say, a1, actually not a1, what is the first number to be divisible by both? Let's say it was k equals 34, right? So k equals 34, that's this guy right here. So that's 8, 3, 9, 5, 4, 2, 5, right? Let's see if I can explain this. That number is divisible by both 9 and by 5. Okay, you can check that out. It's divisible by 9, and it's also divisible by 5. Okay, so if it's divisible by both 9 and 5, it would therefore be divisible by 45, which is 9 times 5. Got it? So if a number is divisible by 45, then that means, then let me just remind everybody what this was. This was A34. So that means that A34 all squared would most definitely be divisible by 45 squared, which is 2025. So that's what I think they were doing there. I'm not sure why they did that. It just makes it more complicated, more confusing. But this is sort of the explanation as to why first you find the A's, the AKs, and then you work with the 45 number broken down into 9 and 5, and then that would essentially mean that when you square those A's, they would be divisible by the square of 45, which is 2025.